Section 6.6 Solving quadratic equations by factoring. Part 1. First of all, let's define what a quadratic equation is. Quadratic equation has the following form: ax squared plus bx plus c equals 0, where coefficients a, b, and c are real numbers and a is not equal to 0. If it is 0, then we no longer have a quadratic equation because first term would not be there any longer. This equation, we say, is in the standard form. We also say that it is a second-degree polynomial equation in X. Now I have a question for you. What if I tell you that there are two mystery numbers that after multiplication give you the product of 0? What can you tell me about those two numbers, or at least one of them? Do you agree that for the two numbers to multiply and give you 0 as a result, one of them, or both, have to be 0? We are going to use this principle in solving quadratic equations of the form presented above. The zero product principle says, if product of A and B is equal to 0, then either A or B must be equal to 0. Example 1. We need to solve this equation for x. Negative 3 times x equals to 0. Do you agree that the only way for this to happen is if 0 takes place of x? Therefore, we say x must be equal to 0, and this is the only possible solution for this equation. Example 2. X minus 4 multiplied with x plus 2 results in 0. I must again say that either first factor or second factor are equal to 0. Solving each of these simple equations gives me the following. X is either positive 4 or negative 2. Please notice that in your homework you may encounter the following format for your results. The set of solutions contains negative 2 and 4 listed and separated by comma. If we go back to first example, my solution will look like this. The set containing one possible solution of 0. Example 3. Solve 2x plus 1 multiplied with x minus 4 equals to 0. Using the zero product principle, I know that either first factor or second factor must be equal to 0. Solve each of these equations. After applying addition and multiplication principles of equality, where appropriate, I get x equals negative 1/2 or x equals positive 4. Solve x squared minus 6x plus 5 equals 0. Please notice that this example is different compared to previous examples. Previous examples were given to us in factored form, and we could readily equate each factor to 0 and solve each small equation that we get after that. In this example, example number 4, we must first factor this equation by ourselves, and only then we can apply the zero product principle. Let's factor this trinomial on the left-hand side. I used the trial and error method on this simple quadratic. Leading coefficient 1 makes factoring easy, and having a constant of 5, which is prime, also makes it pretty simple to do. Now that I have a product of two factors equals to 0, either first or second factor must be 0. I set each factor equal to 0, then I solve each equation, and I get two possible solutions, 1 and 5. Example 5. Solve 4x squared equals 2x. Please notice that this equation looks very different compared to the previous examples. And it is in part because we don't have this quadratic written in standard form. Let's do that by subtracting 2x on both sides first. Remember that in order for you to use the zero product principle, you want your equation in factored form. This time, I don't have to use the trial and error method. I just factor out the GCF of 2x. Now I have three factors in fact. One of them is 2, another one is x, and third one is 2x minus 1. I could set each of the three factors equal to 0, although setting 2 equals to 0 makes no sense, so we can just leave out a constant factor and just set factors that contain a variable equal to 0. There are two possible solutions to this equation. One of them is x equals 0, because there's nothing I need to do to solve it. It's already solved. My second equation requires some work. I solve for x to get 1/2. Therefore, the set of possible solutions for this equation is 0 and positive 1/2.